All right, what's going on, everybody? Welcome to the channel. Yep, that's right. Another video on classes on internet because I guess internet didn't have enough videos on classes already, so I'm throwing my own. So we'll be talking about classes, some design, some best practices. I have the agenda that we'll go through, but we may not follow as it is. Let's see like how where it goes when we start explaining the things. So grab a coffee, lower your expectation, and hit the subscribe button if you want to come back again. All right, so let's go. So here's the agenda. We'll talk about class features, constructor initialization, destructor, and smart pointer with respect to classes. We'll see memory layout. We'll talk about namespace organization if you're interested in. Uh, and we'll overall go over the modern best practices using classes after the evolution. Yeah, so the top for the first, we'll discuss obviously the classes. So I assume that you don't know the classes, so we'll go over the classes. And evolution of classes means we will talk about rule of three. We'll see the raw pointer as well, although it's not recommended, but it's good you to know. We'll talk about move semantics in C++11, and here are the other concepts we'll go through. But I'll just give you like very high level idea. So we'll go to the constructor in more details. We'll see some of the key special member like delete or default, and we'll talk about initialization technique. It's such a big topic in C++. Like for any other language, it's like how do you initialize? 2 minutes. In C++, we may have the whole video on just on initialization techniques. And once we understand constructor, we'll talk about destructor and ultimately rule of zero, RAII. And here are like some topics with smart pointers in classes, memory layout, and organizing your code. So I think in this video, we'll just follow the traditional way, uh, not including like C++20 module. And yeah, so this is, and we discuss namespaces. I see often we don't discuss namespace much, but I think this is less visited topic, so we should discuss and discuss model patterns, basically rule of zero, use of the keyword override and final, and all these topics will come back to the slide again, and then some takeaways, and then Q&A. So that's the agenda for this video. So here we go, classes in C++. So you ever look at your code and say, wow, this is the mess. You have all the variables and functions all over the place. Now you think you want to organize it. So that's where classes comes in. It's like taking all your junk, your variable, your functions, your random crap, throwing into a box with a label on it, and boom, it's organized, and it's the classes. So this box thing called class, it's like a blueprint. All right, you can define a data type that serve as a blueprint for creating classes. One of the core principle of object-oriented programming is encapsulation. That is basically bundling your data, your function like behavior, and controlling through some access specifier like private, public, etc. We'll talk more about it. And then classes enables this encapsulation. So this is like the starting point of understanding object-oriented programming. So this access specifier like public, private, protected, you can think of it like a bouncer for your code. You don't want some random line of code messing with your variable. So some random code say, can I change this? Your specifier would say, no, it's private. You can't do that. So class is defined using a keyword class with some name. So let's create a class for stock because I was trading and losing money. So I just want to discuss this stock class. So It should have let's give this a stock some name. So I'll make this private, and we call this sticker. So we create sticker as string, and this is stock should have some pricing. So we'll use double, and this is my price, which says the current price. So the current price are my private members. So this can be accessed only through some public methods outside of the classes. So let's declare some public methods. Create setter and getter. So let's say this set price, and this is basically this dot price. It's not dot, it should be this, and another method to get the price. Oh, so let's say this is const, and can return just price. So this is my simple stock class. This is blueprint. We can create multiple objects, and let's create a stock apple. And this is, you can just declare like that, and now we can set some price to this, and let's say this is $200. So when we say stock apple, or let's say I say like a stock Goog, then a little magical thing get called when you create an object. It's like birth of variable. So congratulations. Here we just created two variables, apple and Goog, called constructor. And here we did not declare any constructor in our code. That means compiler is creating certain constructor for you. That's called implicit declared or compiler generated constructor. So there are, like, if I don't declare anything, there are 5 constructor that compiler would generate. So the main one are default constructor, then copy constructor, then copy assignment operator, destructor, and after C++11 you have like a move constructor and move assignment operator. So you'll see, like, even without declaring those constructor, when we write code for copy or move, it will work because compiler has already created under the hood. But compiler does not directly tell you which constructor it generates. So let's declare a default constructor. So that is basically your class name, and we can just print out some message, and this is my default constructor stock. So I declare two variables, apple and Goog. So every time we declare this, default constructor would get called because we don't have any other constructor and we're not passing anything. So if I run this program, you will see 2 times we print this. So you can just like quickly check default constructor for stock 2 times, no surprises. Now, so for Goog, instead of declaring like that, we switch this statement here. So first I declare apple, set the price as 200. Now I want to declare Goog using apple. So if I declare my variable, this is and I'm copying apple to Goog. Let's see, like, if this will also invoke some constructor. Let's see if it invoked this constructor or no. So let me run this program, and here is the result. So we have just one time this got called default constructor in case of when we are declaring apple. but it's not for Google, because here uh, the, we are calling the copy constructor, not the default constructor. So the compiler is creating copy constructor for us, and we are just calling that constructor to declare my Goog. So we can test this out. We can create our own copy constructor. So let's say this is my stock class. I'm taking this as reference. So this is and here I'll just say this is copy constructor. Copy constructor. It's like saying, hey, make me clone of this object. Same values, but a different guy. Yeah, so let's run this, and no surprises. So first we have default constructor, and for the second we have copy constructor printing from this. And let's say now you want to create another object. Well, but wait, you said, oh, this Google is just like Goog, so I want to assign Google to Goog. Let's print the price of Google. So I just go with cout Google dot get price. That's what we need. And the oh my god, there is this error in cout. Why? All right, okay. Yeah, so this is the reason. I think okay, I didn't pay attention. I just like declared. So first of all, this should be double. It's returning double. And I didn't use keyword return. Let's see if it will work. Basically in Rust you don't need to use a return as the last statement, so you could just use this, and this means like it's returning. I don't think it will work for C++. Yeah, so this build has failure, so we have to use return. Sorry about that. That's because when you're working with different language at the same time, so my C++ got rusty. That's a good joke. So here's another issue. Why we are not getting 200? Like, why this random junk? So let's review the code again. I think this will be helpful. So so what we are doing, we have this apple set to 200. We use copy constructor to assign to Goog. But in our copy constructor, we are just printing out the message. We are not doing any, we are not actually copying. So let's like for a second, let's just comment out this and let compiler generate it, and then let's run this and see like if compiler drew the member level copy, and it must. So this is like I don't see the message, but that means copy constructor get generated by compiler, and it is actually doing member wise copy, and we get 200. But when we define, we did not copy, so that's why you have uninitialized state. So how do you fix this? So you must specify explicitly to copy the data member. We could just use ticker. Say this will be others.ticker, and price. It'll be just other.price. This other. This is my other style, and now I am copying. I'm actually copying the values, not just printing. And when this Goog has the value, and I'm assigning to Google. So compiler is generating another constructor and copying the member values. Let's try this one first. Actually, we already saw this, but yeah, let's try. So now we have 200. It's fixed, no issues here. So your copy constructor must actually copy all member variables. So if you leave the body empty, or if you don't initialize, you will have an initialized value after the copy. Now we can quickly declare another constructor, copy assignment constructor. So this will return my stock class. Uh, we are doing operator equal. So basically what you're doing is you are overloading equal operator for your class, and this is the other class object. This is overall, this is your copy assignment. And it must return the object. So we just return this pointer and it should work. So here the same, like we are defining copy assignment constructor, but we are not actually copying. So once we do this, Google is not getting the value from Google. It's like some random values. So let's yeah, quickly run this and see. Yep. So again, like here you see this copy constructor get called when we do this assignment, and we see this message copy assignment for the stock, but there is no actual copying we are doing, and that's why it's some uninitialized state. So let's copy the members. So here ticker equal to other dot ticker, and price equal to other dot price. I would also want to check that prevents this type of bug. Something. Let me first write this if condition. So I want to check if this object is not equal to other, then only I would do the assignment. So basically, I'm saying like if you have object s and if you do something like s equal to s, this will prevent this type of let's say like bugs or yeah, then I don't want to do the assignment. So this is simple if condition, and it prevent unnecessary work. And as I'm returning this pointer, this allow chaining something like a equal to b equal to c. Yeah, so before moving ahead, let's run this code very quick. Okay, whereas so here we have 200, no surprises. Why do you need to write this constructor? So the reason is C++ do member-wise copy, but if you have pointer in your classes, then you need to implement your own to do the deep copy. Otherwise, if you just have pointer and then C++ member-wise copy, you would get two objects point to the same memory location, and one get destroyed, the other get destroyed as well, and then you will have multiple exceptions. We'll go through this example, but first we just need to understand what is the copy constructor, what is copy assignment. Next, let's discuss the move constructor. So next, let's discuss the move constructor. I'll remove all this, and let's say now we have Apple, and I want to create another object. Let's say AAL is, and then I want to use using my original apple. So this apple is going to die. I don't need this, and I would just say uh, C++ that you take the apple object. So I'm basically saying is I'm done with this apple object. You can take its resources without unnecessarily copying. So in C++11 said that maybe we stop copying giant chunk of memory like in 1998. Maybe we just grab the internal, leave the original object in safe but useless state, and boom. That's what this move and move constructor comes. So, but after moving, you can still have Apple at that price. So I can still try to print this, and compiler will not complain, even though we kind of said that I'll take the ownership of Apple. But in Rust, if you later when you learn Rust, you will see the same concept of ownership. But if I try to, after taking the ownership of Apple, if I try to do this, compiler will complain that no, you can't do this. This is gone. So for this, C++ introduced L references, double ampersand. That's a way of saying that, okay, I'm done with this object. Yeah. So let's run this code, but let me also print AL prices. So here you see we have copy constructor invoked when I call this move. So in this case, compiler did not create a move constructor, and we both the objects get 200. So this is interesting, and this is important to understand other concepts. But I want to emphasize one fact is when we have a copy constructor and we don't have move constructor, compiler fall back to copy constructor. So let's quickly comment out this part, and then so in this case we don't have copy constructor, so a move constructor would have get created and assigned 200 and its original 200 price, because it's int or like it's a double, so it get copied. But we didn't explain things using a string that we should do now, but I'll just explain so that we don't get surprises. So if there is a string, then a string would move. There is no copy, so the original string of apple, which is sticker, would be blank. All right, so I'll uncomment this code, and we'll discuss more when we discuss rule of 3, rule of 5, rule of 0. And here, this move, when we don't find move constructor, compiler would just use copy constructor. So let's create a move constructor here. Stop, and it accept our value reference, and that we indicate using double ampersand. And this is my error. I use the keyword no accept that we can discuss shortly. And I'll copy this. So this is my move constructor. And here, let's set the price of other to 0. And here we need to use move. So if we are moving, it's a string. Yeah, so this should be a move constructor for us. So one point to note here is, so here I say this other is my L value reference. That means it's a temporary object with double ampersand. But inside this function, this is for me like a local variable. So its member, like ticker, is L value reference. So if I don't use move, it would get copied. So even though we say this is our value, we should use the move keyword to move the string, move the sticker. And here, like, we don't need because it's just double. So anyway, it will be copied. So again, slowly, this move tells compiler to treat other.ticker as our value reference. And so this cast to our value reference, and that enables the move constructor or move assignment of this string, because this is the string. So this will invoke the move constructor of a string, and that's actually perform the move. Otherwise, you get a regular copy. I hope that makes sense. So now we can run this program and see. So now we see move constructor for stop, and apple is set to 0 and 200 is AAL. Let's talk a tiny keyword we used, no except. Uh, so thing with C++ is it's such a big language. You have to learn when you're learning, let's say, classes. You will learn a little bit of pointer, a little bit of smart pointer, initialization, etc. And then you focus on a smart pointer only, and then you learn a little bit of classes here and there. So I think that's the way to go. And so we can quickly discuss no except without going into much detail. So this no except is a, in if you will see, like, in function declaration, we use this to specify uh, and kind of saying to compiler that this function is guaranteed not to throw exception. So there is no exception when we add this. So why this is important? Performance. So compiler can generate a better, faster code when it knows that this function won't throw any exception. But you will often see this no except in your move assignment or move constructor. So in few cases, if you don't have no except, then compiler for STL will end up using copy instead of move constructor. So they prefer only if it's guaranteed that this function will not throw any exception, and you mark with no except. Otherwise, just like the previous example we saw, compiler will fall back to copy, and then there is no advantage of move, it's slower. So if I don't use this keyword, I can remove it, and there is no issue. Compiler will not complain. It's just in some cases in STL, when I try to move my object, it will not actually move, it will just copy. So let's declare this AEL in a little bit different way. So here I create this AL object first, and then call, then assign, and using move. So this is a move assignment operator. So we can probably, so at this point you shouldn't be surprised that this call will invoke copy assignment for stock, and compiler had not generated any move assignment constructor. So you can remember this as a C++ rule. So if you declare a copy assignment operator, but you do not declare a move assignment operator, then compiler will not generate a move assignment operator for you. So even though you write this move, Apple, it will just copy and using copy assignment. So the compiler will fall back to copy assignment operator. And I think this is the closest match compiler can find. So how do we fix it? We can declare our move assignment operator. So let me just copy this piece of code. This is returning reference. Instead, I need our value, and I would just use accept keyword here. So this is my move assignment operator. and here or two I would move this trigger. So great, now we got real move. So the bottom line is, if you declare a copy assignment, you should always declare move assignment as well. That's called rule of five. This is like part of rule of five. We started calling after C++11. So, and then we'll go into the reason like why you want to have your own copy assignment instead of compiler generated. But if in case you have this, you should also have this. So let's quickly run this and make sure we are not making any mistake. Alright, so we have move assignment for string. Both are 200. Alright, so now let's add a destructor to our code. So for destructor, it's simply, the syntax is tilde name of the classes. Or is it tilde? I don't know. Yeah, I'll call this tilde. So tilde name of the class, and that is your destructor. So this tilde in C++ is used for destructor, and the sign you can also see in like bitwise operation. So here it's basically, you could think of, it means destroy or clean up of this object when it goes out of scope. So this destructor automatically gets called when our object goes out of scope. So here, if we run this, two object goes out of scope, Apple and AAL. So this destructor is called for each one, and destructor first stock got printed out twice. So it's a job to clean up resources like releasing memory, closing files, etc. But in our case, we are just have string and double, so we don't need anything special. It's just a standard type cleanup, and it clean up after themselves. So when your class will hold a pointer to dynamically allocated memory using new, then you must release it in destructor to avoid leaks. And even if you don't have that, but it's good to understand the life cycle of the object, and it's good for debugging purpose. So C++ doesn't have this memory cleaning services that will come and clean garbage for you. So you created two stocks, you should clean up yourself. And destructor are like taking the trash out when you're done. And if you don't take your trash out, this place will smell like memory leak. But in programming language like Java, Python, I think like except few programming language, in all the programming, you subscribe to this service, this garbage collector service. That would cost you, but the benefit is they will come to your place, clean up the garbage. You don't have to do anything, but you have to pay the price. All right, so now we are making the stock objects. So we have default constructor, we have destructor, and we are creating stock Apple. But let's say you want to give a name and a price and the time when you make those objects. You don't want some empty objects flying around. So that's where parameterized constructor comes in. So we can create a, let's copy this default constructor and pass const, so I'm taking reference to a string and double p and assigning to my ticker and price. So this will be ticker equal to t and parametric constructor or stop. So here's the small issue. So if we do this way, so this for this string, it get first default constructed and then it get assigned. And compiler would be like, why are you making me build this thing twice? So I have to first default construct your string and then gonna assign it again. Like, why extra work? So why don't you use initializer list? And using the initializer list, it's like we are saying compiler that construct these variable exactly from the start. Don't waste your time or my time. So let me comment out this. So the better way to do is ticker C price. So you must use initializer list because it is direct, efficient, and it's the recommended way. Using like this, it's like you get your grocery and then before putting into the fridge you put it on the floor and then you take from the floor and put it in the fridge. Why dumping on the floor? You just straight away put them in fridge. So that's what we are doing it. So now we can create this Apple object. Let's say this is $200. Yeah, and let's create another one. So this is you with, and this is my $100. I'll create a display function because both of them are private. So let's print use display to print out ticker and price. So I can remove this now. Let's print apple dot display. So this is fairly straightforward. Let's run this. Okay, so we call parametric constructor twice first off, and we assign Apple to 200, Google 200, and then destructor got called as these two objects goes out of scope. So here the way we initialize this is called constructor initialization, or you can also say like direct initialization or parenthesis initialization. So you are calling a constructor explicitly, what we just declared, with the argument in the parenthesis. C++11 also introduced brace initialization. So if you see, I can let's create another Google and then I can use this curly braces to initialize let's say 700. So this was introduced to unify initialization, and I think we will have a separate video just on the initialization. And there are because this is C++, so every small thing worth a video. Let's create another one for Microsoft. Let's say this is 500, and we can display both as well. So all these three way, one is direct, and then you do curly braces like this, or you use like equal to curly braces, all three under the hood doing the same thing, calling the same parametric constructor. So we can quickly check that. Yep, so you see we have 4 calls to parametric constructor for stock. Here there is absolutely no difference. Difference you will see when you use initializer list in your constructor, and then there are like 2 different ways, or sometimes you will see in the built-in function. So probably if I would declare, let's say int p, and if I say this is 3.14, let's say this is pi, this will not compile because for brace initializer, narrowing conversion is not allowed. But if you would just use int, let's say this is my pi1 and I can use 3.14, here there is no issue. So let's run this and build it, and let's see what is the error. Yep, so here in brace initializing, it gives you error and it says conversion from double to int requiring narrowing conversion. But if you use the parenthesis, you get the warning of possible loss of data. So this is one example, but like I said, this requires a separate detailed video to just go over all different way of initializing, and there are a lot more detail to cover over there. So here all looks good. So next, let's say you want to let's say I declare some stock as, but you want to stop people making empty stocks, because in your application it doesn't make sense that a stock would exist like S without any name or without any price. So what you want is you want to prevent default construction. So this should give you error. So in here you could simply make a default constructor and disable using the delete keyword. So I could go stock equal to delete. So it means no default. It means no default constructor, only allow parameterized construction. You can see here, if I declare S, it says default constructor of a stock cannot be referenced. It is a deleted function. Similarly, there is another keyword called default. So by saying default to any constructor here, you're simply saying to the compiler that do your things. Give me the default behavior, give me the basic constructor, and you implement whatever you need, and the rest compiler would generate. So now you see now this error disappearing. So this is about delete and default. Let's say like if I don't let me comment out this. So if I don't declare this default constructor and I don't have this, I just have this parametric constructor, and here there is no default constructor exist for this classes. So what's happening is, if you, let's say, if you declare no constructor at all, so the compiler will go to its default behavior and give you default constructor, move constructor, copy assignment, move assignment, and destructor. Six functions. But let's say if you declare any of those constructor, then compiler thinks that now you are taking charge, you do things, and I will not generate any for you. So in those cases, if you want to do some special constructor, but you also want the default behavior or default, you want compiler to generate those default constructor for you, then you would use this default key. That would turn out to be very handy for you. So you need to spell out what you want. Compiler is not the mind reader, and it sometimes get moody. Let's consider another example. So this we discussed, and I don't need all this. So let's say like here, basically we are passing this string, and this is our value, and the constructor we have for parametric constructor is for L value. So here let's understand using this example. So if I create a string, let's say name apple, and I would move this name. So now my name has moved to stock. It is ticker get initialized with the name. So if I would print name, what do you expect the name would have? So let's run this. So we are calling this parametric constructor and destructor here. When we print the name, it's still Apple. It's didn't get moved. Seems like somehow it just copied, and we lost all the benefits of move semantics. It's just simply copying. So in our constructor here, we only accept this not with the double ampersand. And when we call this move, it just fall back to copy semantics. So if we really want to get the benefit of move, we should create another constructor. Probably we'll discuss this later, what we should do or what we should not. But anyway, I want to let's say this parametric move constructor was stop. So I'll remove, let's clean up a little bit code. Let's run this. Yep. So as expected, this move parametric move constructor got called, but I still see the app. So this is not moving. So I think, yeah, here I made the mistake. So if I want to move, I should be using this move keyword here. Let's explain this earlier. So the first of all, you would never use const here. So otherwise there is no point of moving it. And so this, you're telling compiler or that this stuff is not needed. So you will move that and assign to ticker. So if you don't use this move, again, this is just telling the compiler that this stuff is not needed. And if you don't move, then you are just simply copying. Yeah. So here when I move my name here, I'm telling my compiler that I'm done with this. I don't need it anymore. So just take it. You can have it. And in this function, when I use this move is like your little U-Haul that would take all the stuff, dump into the ticker without copying and all. So let's run this, and you see now I try to print name and it is a empty string. It's and here you can see that it's use of moved object. So I'm just printing out my moved object. You see now we are calling this parametric move constructor. So the rule of thumb, sometimes people forget to do this move. So if you're using double ampersand, you have to use move. Otherwise, you are just pretending, you are just copying. So here we discussed the class and its constructor without using pointer. So once we use a pointer, means some dynamically allocated resources, that's where the real complexity comes. And then you must have heard of rule of 5. And rule of 5 is basically you must define or explicitly delete or default all 5 special member functions to ensure that your resource is managed accordingly, avoid any leaks or double freeze. And those 5 are your destructor, copy constructor, copy assignment operator, move constructor, and move assignment operator. So all those we have discussed. So in short, if you have a pointer, you better write all 5. In here, like we didn't need to, but we just want to understand and without introducing the complexity of pointer. And from the next part that we should discuss in our next video, I think we could conclude this here and say this is a part 1. So in the next video we will go over the rule of 0. That means using the smart pointer instead of raw pointer, and let C++ do the babysit for memory. And we don't need to write so much boilerplate code. All right, so that's it. Classes and constructor in C++, your little team of construction worker making and breaking your objects.